start with the lab session, and I hope everybody is ready with the system, but don't worry, we are not going to start right now. Let me explain what we are going to do today so that you can start working on it. So today we is the hardware and software lab, but we are trying to concentrate more on software lab, and if you can complete this exercise, then we can move to the hardware lab, right? So here we are going to study 4 different signals. When we transmit a message, the message travels by means of a signal. So the signal can be represented either in a BPSK or QPSK or QAM or OFDM. Right? The modern signals all we are trying to look into OFDM mostly, but earlier we have to start with BPSK 2-level phase shift keying, 4-level QPSK, quad, and we are not looking for the primary QAM signal. We are going for a M array QAM signal where M is 16. As we are trying to look into the theory, we have seen that as M increases, the spectral efficiency increases. So 16 is we will be doing in the lab, and you can try also with 32 and 64 also, right? So these are the 4 modulation schemes we are trying to see. We transmit the signal, and then we try to decode it back and see whether the transmitted signal and the decoded signal are same or not, right? And we try to pass the signal through 4 different channels. One is AWGN channel, the second one is Rayleigh channel, 4th one is Ration channel, and 3rd one is Ration, and 4th one is Nakagami channel. Okay, so if you try to look from the wireless communication point of view, mostly we try to use the last 3, not the AWGN. AWGN will help us in understanding the system, and once we know it, we move on to a line of sight and non-line of sight and use fading channels, and the Nakagami gives you more closer. By playing with the value of M, you can either move towards Rayleigh or move towards Ration channel, depending on the environment. So if you try to look from the AWG channel, it is mostly, you can see that the signal is affected by all the frequencies, it's not by one particular frequency. Most of the cases what we try to see is, if the frequency is narrowed down, some noises will be affecting, the other frequencies will not be affecting. So that's how we move from frequency hopping, where there is less noise, we move to that frequency and try to work. Instead of that, we should know where exactly it is affecting. So the pattern what we are trying to look from AWGN will not give you any idea about the channel. We are taking a flat channel, having the noise effect similar for all the frequencies, and it is only for knowing that how the channel has to be modeled, we try to look at it. Then we try to move on to the Rayleigh fading channel, and you can see that most of the wireless today's system, they are not line of sight. We call it a non-line of sight, like mobile phone. You don't go directly opposite to the base station and talk, right? So as we move on from the fading channels, we move to the Rayleigh channel, which gives you more towards the no line of sight. We call it as NLOS, and we can see that the signal comes from reflected path or refracted path or diffracted or scattered paths, and then receive the receiver. So in that case, we use this one, and you can see that interference has multiple components, and we can handle the channel mostly using Rayleigh distribution, and this will help us to understand how the interference or the fading is affecting the signal. Then we have Ration channel. It is dominated by LOS, and you can see that there is a parameter called K, which will help you to understand much better. If K, there is a K value which is equal to 1 and greater than 1. You are supposed to look into that factor. Play with the K and see how the channel is being affected with it. Okay? And mostly you can see that this is a very good model for satellite communication, because you have a direct signal from satellite to ground station. There is no path between or obstacle between that, right? So you can see that most of the satellite communications, they model it using Asian, whereas mobile networks comes under the railing. And you can also see that if you have a small urban micro or picocell means you have a access point and your laptop, right? This is direct line of sight. It is not line of sight. You are not getting signal from reflected. Dominant is LOS. So when you are trying to look at a small micro cells or picocells and all, it is mostly dominated by LOS. So you can see that the satellites and the micro cells and all, they come under ration trading channels. If it is obstacles like urban areas and all, it is predominantly we go for railing channels. And we have a very good one called as Megagami channel. It's a statistical mode where both can be realized in it. Right? It is not that it is railing ration. There is a factor called M. It tells you whether you have to move towards railing ration. So it gives you a better understanding. If you are moving towards the channel, something like rural areas or urban areas or semi-urban or dense urban, you can play with them and reach to that point. Right? So you can see that dense urban environments are multiple strong multipaths are coming and now Nakagami channels are much better. And you can adjust the channel such a way that you can cover all the regions. Rural areas you can cover, towns you can cover, urban areas, dense urban areas, satellite networks, all these type of satellite townships and all you can cover with it. Even if you have inside your house, there are number of reflectors, like Almara is a reflector for you, right? There is a table, steel table, it is a reflector for you. So in those models also this will help you a lot, right? So with these 4 channels and that 4 models, we try to do the MATLAB coding for that. So before we go, I'll just simply explain a simple code and then you can start working on it. So let us take the first code, what is called as VPSK code, modulation and demodulation for AWGN channel. So if you try to look at the first 3 lines, what we are trying to do is we are trying to clear the contents what are there in the memory, cache memory at that point. You write CLC, clear all, click close all. Means whatever is open previously, you are trying to close everything and making the screen ready for your program. Okay? So whether you like it or not, you have to add those 3 lines. Right? So make it a habit, like whenever you open a MATLAB code, you just put those 3 lines. Otherwise, the last executed program can affect the present program. Right? So then you have n is equal to 50. The n is number of points you are trying to consider it as you go along. First n is equal to 1, 2, you are repeating the cycle up to 50 points. Like you are taking 50 input points and you are trying it. So that n, we generate it from the data. You can see you are generating a random data of zeros and 1, 50 numbers. Right? You are generating zeros and 1, 50 numbers you are generating. That is what n is. Right? Random data we generally write 0 and 1. You want n 50 numbers of such type. And that is the binary data what you are taking. The SNR value is 20 dB actually. Okay, so you can vary the dB also, 40, 50, 60, you can do it, and also you can increase it or decrease it. Okay, so there is a built-in routine for you, which says that there is a VPSK tool which is available, which you can use it directly, right? Hello, sir, good afternoon, 5 minutes and I am coming down. Yeah, sure. So that is what we are using. There is a built-in routines like BPSK or the QPSK, QAM and all are built-in routines, toolbox are there. You are just using that command and calling that routine and using it. Right? So that what you are doing, you are taking 2 into data minus 1. So your data is 0 and 1. So you are multiplying 0 with 2. So it is 0 and minus 1. So the result is minus 1. But 0 you are representing by minus 1. And if it is 1, you are representing by 1. So you are using minus and 1 for 0 and 1. It is 211. That's what BPSK is. Right? So you are taking 2 into data. Data is 0 or 1 and minus 1. So you are representing the data 0. So you are plotting that and seeing what it is, and these are the titles you are giving it for the plot. Actually, I don't have it. I think the manual, if you try to look at it, you will get it. I think that will be circulated to you. The data will be, for 0 you are giving minus 1, 1 you are giving 1. And this is the x-axis and y-axis what you are filling up. X label is time, y label is amplitude, and title of the graph is input data. So this is what you are trying to fill it up. Right? This is only for plotting the data, how it looks like. And then you can see that the figure is complete. And there is another figure which you are trying to plot, BPSK modulated data. Earlier you are taking zeros and 1, and you are now representing BPSK modulated data minus 1 and 1. Right? So next, you are trying to transmit the signal through a AWN channel. AWN is a function already built in. You are calling that and passing the signal through it. Right? And you are plotting that again with the labels. Right? And then you can demodulate it and then plot it and see the data. So the MATLAB has a built-in codes, everything. We are trying to call the functions, using it for our signal, and plotting it and seeing what is at every stage of it. Right? So it should not be that difficult for writing a MATLAB. If you are starting writing a MATLAB code, it should not be that difficult because they are all standard instructions for us. We are only trying to use that function. And these are plotting routines. This is for every graph. You need a x-axis, y-axis, title, and what are the points you are representing. That's all we are trying to do. And you can put on a grid so that you can see on the grid where are the points. If you don't put this, the grid will not be on a plain sheet you can see. Right? So just spend some time, understand the code, and then try to run all these codes and see how it is. Okay? And if you have any problem, there is Harika, right? Harika and Paul are there. They will help you out in running the codes and see that the program is executed properly. Okay? You can start working on it. You will be here only, right? And see that it is all the things.
Such kind of things.
In India, now starting of the time, you don't know that you are surrounded by women.